In many of my projects, I found it helpful to have some utility PCBs to really help with common, just basic things like power distribution and reset circuits and clock circuits. And in my recent videos, you've maybe seen a couple that I've been using. I've been using a power distributor, and I've been using a reset and clock card. As I've been working with those, there's little things I've wanted to improve, and I finally decided to actually spin up an update to those cards, and I'm going to consolidate them. And I'll show you what I'm going to get ordered up here. Looking for any feedback if you have it, suggestions or minor enhancements that you think would be good to consider. Let me maybe start out with the existing cards that I've been using. I've got a power distributor, and what you're seeing here on the screen is that PCB layout, and maybe I'll just pull it up in a 3D view so that I can walk through this real quickly. All this is a bunch of different connectors connected to the same VCC and ground. So I can bring power into any one of them and then tap into any of the other connectors for output. And you'll see that I use these DC barrel connectors. This footprint here lets me use either a terminal type connector or also these quick connect connectors that I've been using quite a bit of recently, and those are all really handy. And then I've also just got little pin headers, and I can either put male or female in there, I guess, and use that to connect to breadboards or simple little things. And then I sprinkled around a whole bunch of spots for capacitors if I feel I want to put capacitors in. Probably not necessary, but I typically do put in at least a couple good sized capacitors here on the left, and I think the one I've been using recently, I do have a bunch of these capacitors populated. So simple card, and if I look at the schematic for that, it's just a bunch of connectors with VCC and ground connections. So along with some capacitors, and that's, I mean, really it. There's not a whole lot there, so nothing too exciting, but it's helpful when I'm working on my projects, that's for sure. As far as my clock and reset that I've been using, here's what that looks like, and I'll maybe go into a 3D view. Ignore the size of the capacitors and some of this other stuff. This is just how these components that I selected in Easy EDA are being rendered. But if I walk through this real quickly, power comes in, I've got an LED to show me I've got power, I've got an LED to show me the reset status, I've got a reset switch, and I've got a switch here so I can manually pulse the clock. And then I've got a switch that lets me switch between auto and manual clock. I can flip the source of the clock between a 555 circuit, and you'll see these 555s up here for that, and an oscillator, which is just sitting right here. This dip 14 that you can't see very well here is just a flip-flop, so I'm with that flip-flop generating both a simultaneous positive and an inverted clock, so that works great. And then I've got some pin headers to connect to the reset line, clock, or an inverted clock, and I can also bring in a halt if I want to halt the card. I don't use that halt too much though. And as far as the schematic for this is concerned, there's a section up here that really is going to get me into the reset circuit, and that comes from one of the old 70s computers, one of the standard circuits used back then. So I've just implemented that here, and then down below I've got my entire clock circuit, and really it's just a bunch of 555s, some other miscellaneous logic gates, and that flip-flop. And that's about it. The rest of this is just pin headers, capacitors, LEDs, resistors, and different connectors, and some standoffs. So quite simple. Once you look at that, there's not a whole lot to it. But those are the two cards that I am going to bring together now into a single card. And let me maybe walk through that schematic here real quickly. All I did is I took those existing two and just brought in all the pieces, and I added one new thing. Now I have to admit the schematic is kind of a mess. It's not well organized, so you can dock me on my schematic here, because I would dock myself, but it's good enough for what I'm trying to do here. I do have a VCC in section, so I am splitting out power now. Power that comes in does not automatically go out to the rest of the circuit. And I want to have a few ways of bringing in power, and I've got a relay that I've now put into the circuit. And I'm going to show you this in the 3D version here in just a second. The other enhancement that I've made to this that is going to be helpful is that I've added an 8-bit counter that I'm feeding the clock into, and that means that I can pull out a 1/2, a 1/4, a 1/8, 1/16, etc. From that clock. So if I was to pull up the 3D model of this here real quickly, let me first of all get over to the PCB view of it. And so this is what the PCB looks like. Maybe you will notice right away I've got some pretty big traces on here. So if I go into my design rules, I am using a 2mm width for anything that is VCC or ground, either incoming VCC or the outgoing VCC, and then ground I'm using a 2mm. And I think if I've got the calculations right, just using this little online calculator, 2mm traces, 1 ounce per square foot for the copper thickness. Maximum desired rise temperature. This calculator, the lowest it lets me go is 40 Fahrenheit. So that must be an acceptable rise as far as this calculator is concerned. And I should be able to get, over 2 amps out of this. And again, that's far above what I think I'll need for any of my projects. But if I hit 2.5, that would be a lot of power for the stuff that I'm working on. So I think this power-wise will be adequate for anything that I'll be doing for quite a while. And if I pull up the 3D version of this, again, ignore the capacitors and actual components that are loaded here, but it gives you an idea. So this upper left corner, I can either bring power in through any of these previous connector styles I was showing. I got those 3 up here. I'm also adding banana plugs. So my benchtop power supply, I typically use banana connectors connecting into it, but it'd be really nice just to then connect into this with those same banana connectors. So I can go male banana to male banana as far as a cord is concerned, and just plug in my card straight from my benchtop power supply, which is regulated, so I don't have any regulators or anything like that on this. Then all the other connectors that you might see on here are all output power, but I don't automatically send out that power. I do have an on-off switch now, so I can just simply switch off power at that point. And that is just controlling a relay, and then the relay is what's letting the power through. So that relay is well in excess of what the traces are going to be able to support on this for power. So I think it's a 5-volt 10-amp relay that I'll be using there. Some of this other stuff is just supporting that relay, a diode and a resistor and a transistor, pretty basic relay circuit. I've not used relays in any of my PCBs before, so that's interesting to kind of add that in. Might be overkill, but it seems like a relay is typically a safer option than transistors for switching like that, if the power isn't maybe well known or I don't know what the limits are. So I'm using a relay. I thought that it would be fun to try out. I've got an LED to show that I've got power coming to the board. I've got an LED showing I've got power going out of the board. I'm showing the status of the reset. I can adjust my reset hold here. I can adjust my clock speed down here. I took out the 3-pin jumper for clock source and put in a switch, because I find that I'm going back and forth all the time, and that jumper is too much of a pain. A switch would be much handier. I can still switch between clock type of auto and manual. I can manually do clock pulsing with this button here. The reset is up here. I've got a VCC display that'll show my voltage right here. And then I also added an inverted, so on my previous card I had a resB or a reset bar, same as reset pound or hash. Here I'm also doing an inverted version of that. When I was working on the 6502 and the 65816, they expect an active low reset, but the 286 I'm working on expects an active high reset. So I'm just going to offer both on here. So when I press the reset, it'll behave accordingly. I've still got my halt, my clock, and my inverted clock. And then another enhancement I made is I added a 74F269, or just basically a 269 counter. That is an 8-bit counter, and I'm going to run my clock into it, and that then means I can pull out a half clock, quarter clock, eighth clock, etc. You can do the math, but if I put in a 1 megahertz, that's the slowest oscillator I have. that's going to pull me down. And just so I don't have to try to do math in my head, if I have my 1 megahertz and I divide that by 256, so that gets me down to sub 4 kilohertz. And then if I want to go slower than that, of course, I can switch over to my 555 timer. And I don't recall exactly how fast that typically can run, but fast enough that I can then step over to an oscillator and use one of those counter outputs if I want. So this should give me a pretty good spectrum. And of course I could put in a faster clock. If I put in a 50 megahertz clock, then I've got, you know, the 25, the 12.5, the etc. You know, 6.3, 1.5, all the way down. So I could probably leave in one oscillator and have quite a bit I can mess with without having to switch oscillators all the time. I have noticed that on my existing cards, this oscillator socket, it kind of loosens up or wears out basically. So I start to get a little finickiness in the connection, and I actually have had to swap out the socket because they've gotten loosened up. Or if I ever put in something like a DuPont type cable that has a slightly larger pin to it, or one of the square pins, that seems to cause problems with these sockets that I'm using. And I'm not sure why that happens. They're decent quality sockets, but hoping now I can just put in a, I don't know, whatever speed, a 20 megahertz oscillator, and just leave it in, and then I've got my 10, 5, and I can work my way down and test with different speeds by just simply connecting to different pins over here. You know, in addition to the clock, you know, there are all these power connectors. I've got the barrel connectors kind of spread around. So I've got one upper left, upper right, lower left. Then I've got these other connections on all 4 corners. And then I've got some pin headers in a few locations too that I can use. But if you got feedback on this, any thoughts, let me know. But that is something I probably will order up here in the next probably few days. And then I'm sure it'll take a month before I get it, because I've been ordering everything through the slowest shipping method just to have the least cost. You know, as far as the actual cost of these boards, this is about a $2 board, I believe. So let me just go into fabrication, and I can get 5 boards for 10 bucks, 10 boards for 16, 15 boards for 22. So you can kind of see the math. I know there's a point at which it'll jump up sharply again, but I definitely don't need 20 some of these boards. So I'll probably end up ordering about 10 of these, and that'll be plenty. And actually I probably don't even need that. I might just get 5 of these boards, and then there's probably another $5 to $10 in shipping. So a couple bucks a board basically. But for the projects I've been working on, that is well worth it. I will post the version of the schematic that I have so far on my GitHub. Link is here on the screen. I'll also put the link in the comments of the video. Once I get this actually received in as a card and tested, I'll make any updates to the schematic to fix any problems I find, and I will also post that updated schematic along with Gerber files in the source project, and you're welcome to use that however you might like. So that's about it. I'm definitely looking for feedback. If you have suggestions on how to improve this card, please drop me a note. Thanks.